Here's a wild claim. You've never touched anything in your life. Not your phone. Not your chair. Not another person. At least, not the way you think. When you touch something, atoms don't collide like billiard balls. They never meet. Your hand stops because forces stop it. Zoom in. Way in. Atoms are mostly empty space. A tiny nucleus. A fuzzy cloud of electrons. When two objects get close, their electron clouds overlap. Electrons carry negative charge. Negative charges repel each other. That electromagnetic push is what you feel as touch. There's another layer, quantum rules. Electrons are fermions. They obey the Pauli exclusion principle. Two identical electrons can't occupy the same quantum state. So as surfaces approach, their electrons say, "No closer." The energy cost skyrockets. You stop. That stop is pressure. A table holds you up because its electrons push back with equal force. Stand on the floor? You're balancing against electromagnetic repulsion, not resting on atoms like bricks. So what about hardness? Diamond feels hard because its atoms are locked by strong bonds. Push on it and the electron clouds resist deformation. A pillow feels soft because the bonds and structure give way easily, spreading force over time. But in both cases, you never touch nuclei to nuclei. It's all fields and probabilities. Wait, I feel touch in my skin. That's real. Absolutely. Your skin has mechanoreceptors that fire when surfaces press and stretch it. They translate electromagnetic force into nerve signals. Your brain builds a story called touch. Accurate. Useful. But under the hood, force, not contact. Consider a bounce. Drop a ball on the floor. It squashes a bit. The floor squashes a bit. Electron clouds compress and push back. Energy returns. The ball leaps up. Nothing hit in the classical sense. Forces exchanged momentum. What about friction? That's also electromagnetic. Microscopic bumps lock and slip. Bonds form and break across surfaces. More grip equals more opportunities for those tiny bonds to grab. Add water or oil, reduce bonding and friction drops. And static cling? Same family. Charges move. Fields attract. Your shirt sticks because electrostatics pulls it toward your body until air humidity or contact redistributes charge. Can we ever touch at all? At the quantum level, particles can scatter, tunnel, exchange force carriers. But solid-on-solid contact is a human-scale illusion. Even a punch is a negotiation of fields. Cool tech uses this truth. The scanning, tunneling microscope images atoms by bringing a needle almost into contact. Electrons tunnel across the gap, a purely quantum effect. Measure that tiny current and you map a surface without touching it. So the next time you tap your screen, remember, your fingertip and the glass never meet. Electrons repel. Receptors fire. Your brain says, touch. Physics says, nice story, beautiful illusion. Quick recap. Atoms are mostly space. Electrons repel via electromagnetism. Pauli exclusion forbids identical electrons from piling up. Pressure, hardness, friction, and bounces are force interactions. Touch is real as experience, but contact is a myth. Love reality-bending physics made simple? Subscribe. New curiosity every Sunday.